Okay, so let's say you have a vector that's not in standard form. So for example here, we've got one where its initial point is at -4, 3, so over here. And its terminal point is at 7, -6, so down here. So we've got this vector, and we want to put it in standard form. Well, this tells us up here that if your initial point is x1, y1, and your terminal point is x2, y2, then your a, you're going to take your x2 minus your x1, and your b will be y2 minus y1. So here our a will be 7 minus -4, so this will be 11, and our b will be -6 minus 3, so -9. So this would be the vector 11i minus 9j. Okay, here we have 4 minus and -5 and 4, 3. So our a will be 4 minus 4, which will be 0. And our b will be 3 minus -5, which will be 8. So this would be 0i plus 8j. So this will just be 8j. Okay. Now, a term you'll hear when we're talking about vectors is the resultant, and that just means we're going to add two vectors together. So that's what the resultant is. It's the sum of two vectors. So that's just when you add them to add the two together. And subtracting them is just the same as adding the negative of the second vector. Now, to kind of show you what that means, if we have two vectors in standard position, so let's say this is v1 and this is v2, then to add them together, what you think of doing is attaching v2 to the end of v1. Then if you start at the standard position and draw the line out to the end of v2, that's the resultant. So this angle, let me put it in a different color, in red, that would be our resultant. So that's what we would call v1 plus v2. Okay. Scalar multiplication, if you want to multiply a vector times k, you can, and to do that we'll just multiply the a and the b both by k. If you need to find the magnitude of k times v, it's just the absolute value of k times the magnitude of v. And kv, if you multiply it by a scalar, it has the same direction as k. If it's positive, it's just been scaled out, made k times longer, and it would be 180 degrees the opposite if it's a negative k. So we can add and subtract vectors, and it'll be kind of like combining like terms. So here we have a couple of vectors. We're told that u is 3i minus 6j, v is -4i plus 8j, and w is -2 minus 6j. So we first want to find 3v plus w. So we're going to take 3 and we're going to put our v, and then plus w. So we're going to distribute the 3, so we'd have -12i plus 24j, and then minus 2i minus 6j, and then we can just add the i's and the j's. So our final answer here would be -14i minus 18, or sorry, plus 18j. B here, we want 2u minus 5v. So we take 2, our u is 3i minus 6j, minus 5 times our v, which is -4i plus 8j. So we'd have 6i minus 12j plus 20i minus 40j. Oops, this should be an I. So now we're going to combine our like terms, so we have 26i minus 52j. Okay, next we want the magnitude of 3u. So our little theorem up there told us this is the same as the absolute value of 3 times the magnitude of u. So this would just be 3 times the magnitude of u. So the magnitude of u, we're going to take the square root, we'll look at u up here, so of 3 squared plus negative 6 squared. The square root of 9 plus 36. The square root of 45, which is, 45 is 9 times 5, so this would be 3 square root of 5. So this would be equal to 9 square root of 5. Okay, and then this last one we're going to look at here, we want the absolute value or the magnitude of w minus u. So the first thing we're going to do is find w minus u. So that will be negative 2i minus 6j, and then minus, and in parentheses u, 3i minus 6j. So of negative 2i minus 6j minus 3i plus 6j. Our j's actually cancel out here, and we just have negative 5i. So we want the magnitude of negative 5i, which will just be the square root of negative 5 squared, which will be 5. So our magnitude here is 5. So you can't split them up. You're going to subtract them first, do inside what's inside the magnitude side, and then find the magnitude of it.